Okay, now we're in the pre-processing of the data. Because we have good understanding of this data, we won't need to do any pre-processing of the iris data, but in real life data, you will have to do some level of pre-processing of data. An example of this would be normalizing the data, which is essentially you're bringing the data into scale. So, for example, let's say the x values were had high numbers in the 50s and 60s, and then the y values, the range of numbers were in between 1 and 10. So that means x value will have an overpowering effect when it comes to machine model to the y value, and we don't want that. So you bring it into scale using different methods. Normalizing is a method, but it's based on your data. So if we had done some early data analysis in this project, we would see the shape of the data. The shape of the data will generally will determine what type of scaling you do. So it could be normalizing, it could be a min-max scale to bring it into a range for the model. And then after you unscale it to get the answer in the format you want. I'm not going to go into that too much because that can be for a different video. This video is based on the machine learning model. So in this case, we don't have to scale the data because looking at the dataset.describe function here, we can see that all the data is within the min and max of data are within the 10, so no scaling required. Now, one of the most important parts about and when it comes to running a machine learning model is splitting of the data. In this case, you're keeping some data. No, you're training the model on some data. And then after you train the model on a certain amount of data, then you're going to test the model to see how well it will work on the real world with a portion of the data. So in this case, we're going to be doing 80-20 split. So 20% is the test size. And I'll just go and explain this again because this can get lost if you're seeing it for the first time. The very important part. So when you're training the model, you're telling the model, this means you're telling the model what to look out for. You need to give the model something. So in this case, we're telling the model when you see a petal length and petal width, sepal length and sepal width of this combination is versicolor. Different combinations, virginica. Different combinations, setosa. So when we bring a flower that we don't know. Now the model is only trained on these trees, so it has to be one of these trees. So if we bring a flower that we don't know into this model, it will determine which one it is for us. It will classify it based on the training. So how well you train the model is how well it will work when it sees a combination of petal and petal width that it has not seen before. That's the purpose of this whole project, is to be able to classify the flower based on the combination based on the variables outlined, the petal length, petal widths. Okay, getting too far ahead of myself. So what we do is we import in the train test split from the sklearn library. That's all we did there. Then we're getting the data set and we're taking tree and the first three columns. If you're eagle-eyed, you'll notice that we're taking tree columns. There are four columns, which are the four variables I discussed. Why we're not taking petal width is because if you remember, it had a strong correlation with petal length. So the information to the machine learning model is redundant. So we're leaving out petal width because it's just redundant information. Because they're highly correlated, we know they're giving the machine essentially the same amount of information. And if you can find ways to simplify your machine model, you should always do that. So we've removed that column from this project, and that's why we're taking first tree. And 4 means index 4. I remember what that means. So that's 0, 1, 2, 3, 4. That makes it the fifth column, which is the species column that contains the information we want. So we're going to separate the labels. The labels are being separated from the data, and this is outlined here. So this is the training set, which is 120 tree 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 variables, and then these are the 120 labels for the train set, and this is the test set. The machine isn't going to see this before it's being tested on. It's not going to be trained on this section. This is for testing to see how well it works. It has 30 30 rows, the three variables, just like the training, and then the 30 labels. So it's going to see this, and then when it's being tested, and then it's going to have the labels to check if it was right or wrong, essentially. And now I'll go into more detail when I'm going into how the KNN model works, because it may still be a bit confusing. And yeah, so what else did I not explain? I didn't explain the random set. So random set is like we're not, when we're splitting the day into training and testing, we're not taking um we're not taking a number that is, we're not taking it sequentially. We're not taking the first 80, and say we're working with 100 for simplification. We're working with 100 data points. We're not taking the first 80 and leaving the next 20 for our testing. It's a randomized, and then the randomization state is just set to 42. It could be set to 6. It's just so that we're working off the same randomization, because there can be small differences in it's going to change every time. Your accuracy may change slightly every time, but we just want to be working off the same random state. That's why it's set to 42. You could equally use 600. It's just that we need to have the same random state. I think that's everything explained. And then I just, what I've done here is I've just opened it so you can see, I've just said train data head so you can see what we're looking at. The tree variables is what it'll be trained on, and it'll be trained on the labels associated to each. So this, then that's Satosa, and the machine is being trained on what to see, and that's it. And then next up is how the KNN model works.